Hi guys, this is Lessons 8.1, Equations of Lines in 2-Space and 3-Space. In 2-Space, a line can be defined by the equation in standard form ax plus bx plus c is equal to 0, which is also called the scalar equation, or in the slope-y-intercept form in which we're all familiar with, that's y is equal to mx plus b, where b is the y-intercept and m is the slope of the line. Vectors can be used to define a line in 2-space. Consider a line defined by x plus 2y minus 10 equals 0, which is shown in the graph on the right side. A direction vector parallel to the line is m, which is 2 and 1. A position vector that has its tip on the line is r0, which can be 2 and 6. But of course, this is just one position vector. We can have a lot of position vectors depending where we end our position vector on the standard line. Another position vector, such as r of 6, 8, can be drawn to form a triangle. The third side of the vector is s, and these two lines should actually be connected. The vector r can be represented by the vector sum. R is equal to r0 plus s. Since s is parallel to m, it is a scalar multiple of m. So s is equal to t times m. Substitute s is equal to tm into r equals to r0 plus s to get r is equal to r0 plus tm. This is the vector equation of a line in 2-space. In the vector equation, the variable t is a parameter. By changing the value of t, the vector r can have its tip at any specific point on the line. Substitute r is equal to xw and r0 is equal to x0 y0 and m is equal to m1 m2 to write an alternative form of the vector equation. The vector equation of a line in 2-space is r equals to r0 plus tm, or xy is equal to x0 y0 plus t times m1 m2, where r is a position vector to any unknown points on the line. r0 is a position vector to any known point on the line, and m is a direction vector parallel to the line. Now let's take a look at example 3. A line passes through 2 points A, B of 2, -1, 5, and 3, 6, -4. Write a vector equation of the line. Write a parametric equation for the line, and determine if the point C, 0, -15, 9 lies on the line. In order to find the direction vector, we have to find out what is the distance between the 2 points and point 0. M will be equal to 3, 6, -4 minus 2, -1, 5. That's going to be 1, 7, -9. A vector equation is xyz equaling to 2, -1, 5 plus t times 1, 7, -9. The corresponding metric equation can be formed by using the vector equation. X will be equal to 2 plus t, y will be equal to -1 plus t times 7, that's 7t, and z is equal to 5 plus t times -9, therefore z is equal to 5 minus 9t. Substitute the coordinates of c, which is 0, -15, and 9, into a parametric equation. When we plug in x is equal to 0 to this equation, we will get t is equal to -2. When we plug in y equals to -15, we get t is equal to -2. And when we plug in z is equal to 9, we get t is equal to -4/9. A line in 2-space has an infinite number of normal vectors that are all parallel to one another. A line in 3-space also has an infinite number of normal vectors, but they are not necessarily parallel to one another. And that's the end of this lecture. Thank you guys for watching, and I'll see you guys next time.